Okay, so let's think about the context here. We started with this simpler example where we were just drawing one sample from a population. There was no regression. And I emphasized that you can try to get a confidence interval for mu, or you can try to get a prediction interval that actually covers the whole range of y's to predict the y value of the next person who walks in the door. For regression, so far I've given you two different types of intervals, but both of them were parallel to coming up with a confidence interval for mu, right? We talked about coming up with a confidence interval for beta 0 or beta 1. Well, those are the parameters. That's like coming up with a confidence interval for mu in the simpler case. And then we talked about coming up with a confidence interval for the mean of y given x, right? Given some particular value of x. But that's also like coming up with an interval for mu in the simpler case, because in that case, mu is equal to the mean of y given x. So that means that the next idea is going to be prediction intervals. For a linear regression. So here's the idea. Here's a picture. Here's x. Here's y. And suppose I've taken my data and I've estimated the line. That's where I think the line should go. And what we've said so far is, well, like if you have x naught here, right, and your best guess at the mean of y given x naught might be there, but we also just talked about how to come up with a confidence interval for that. Maybe the confidence interval is like that. And of course, you could do this for any value of x naught. I could choose another x naught up here and come up with an interval, right? I could come up with here, maybe let's put an x bar on this graphic. Here's x bar. Suppose I'm interested in x naught here. I come up with a confidence interval for that. Suppose I'm interested in x naught right here. Come up with a confidence interval for that. What do you notice about the intervals I'm drawing? What do you notice about the intervals that I'm drawing?